Okay, last one for today is 7b from the examples handout, not from the homework. Um, and so I just wanted to go over this just in case you found this stuff confusing. So let's do this. Uh, I put on the right side of the screen over here, this stuff is stuff that we derived in class. Um, and so we can figure out these things just by examining the graph carefully. So one of the things you can figure out is, I mean, it already looks like a sine function, and the midline of this thing goes right down here, right? So the midline is y equals -1, and then the peak is up here at 2, and the low point is down here at -4. So if you think about it, it's a stretch of 3 this way and a stretch of 3 that way. That's also called the amplitude. I don't know if we covered that in class, but that's a term that you probably learned last year. Well, if you think about the basic sine graph or cosine graph, but we'll start with sine. The basic sine graph only goes up as high as 1 and as low as -1. So this one was really a stretch of 3 and then shifted down. Or I guess you could shift it down and then stretch it 3. It doesn't really matter in that case. So what we've got is we've got a vertical stretch here by 3. We've got, now the horizontal stretch is a little bit trickier. If you look at the horizontal stretch, I go through one full period and it takes 4 units to do it. So this thing is directly related to the period. So what I'm going to do is this. I'm going to say the period is 4, right? Well, the period of regular sine, original sine over here, is 2 pi. So if I take 2 pi as my original, and then I have to stretch it or shrink it by something to get 4, the question is, what's my stretch or shrink factor? Right? Well, the only thing I can multiply by, this is the horizontal stretch shrink factor right here. And the only number you can get for this is if you divide the 2 pi over, you're going to get 4 over 2 pi right here, which is the same thing as 2 over pi. Right? So I've got a horizontal, actually that's going to be a shrink because it's less than 1. So it's a horizontal shrink by 2 over pi. Okay. I've got a vertical shift. We already talked about that. That's 1 unit down. So you could write -1 or you could just write 1 down. And then I've got a horizontal shift. Now the horizontal shift, it depends on which function you're comparing it to. I'm comparing to sine right now, and you can see sine starts on the y-axis. And right here it starts on the y-axis too. So it's a horizontal shift of 0 if I'm working with sine. Let's say I wanted it to look like cosine though. Right. Whoa, I don't know what happened there. Ooh. So if I wanted it, I don't know what it's doing. If I wanted it to be cosine, then cosine starts at the peak, right? Well, that's, here, let me draw one full. Let me space that properly. I have no idea why it's doing this. That's annoying now, isn't it? There we go. Sort of looks like that. So this point right here is an awful lot like that point right there. So if I take the cosine graph, this one's cosine, this one's regular sine. If I take the cosine graph and I move it 2 units that way, then, or no, sorry, it's 1 unit because this is just a 1 right here. I'm going by 0.5s. So if I go 1 unit to the right, then I get the cosine graph I'm looking for. So it could be 1 right if I'm dealing with cosine. Let's say I wanted to go for negative sine for some reason. Well, negative sine is the same as sine, but it's underneath. It does the opposite. So now I want a point on my graph that looks kind of like this, where it goes down first. Well, that's right here, and then it goes down first. So if I take the sine graph and I move it 2 units to the right, or the negative sine graph and go 2 units to the right, it's negative sine. There are a whole bunch of other ones you could do too, but any of these will work. And then each one of these gives you a different answer. These 3 things don't change for anything. Those are always the same. So no matter what, your equation's going to be y equals 3 times and then sine or cosine. Oops. Sorry, not those things. All of these things stay the same no matter what. So I'm going to have, like, for this one, we'll go y equals 3, because that's the vertical stretch, times, and I'm working in sine. And then my b is not this. Remember, that's 1 over b, right? So b is really pi over 2. You have to flip them. If I flip this, I get b over 1. So if I flip this, I get pi over 2. And the b is what goes here, pi over 2, parentheses. And then what's my h? If I'm working in sine, it's 0. So it's just going to be x minus 0, which is just x. And then I've got to shift it down 1 unit, so minus 1. So that's the first version. You could have done it with the cosine instead, and you get almost the same thing. You get y equals 3 cosine. That pi over 2 doesn't change. But now I'm shifting it 1 unit right to get the cosine version. And then 1 unit down also. And if I did negative sine, it's almost the same thing again, but it's this. So it's negative sine, so I'll put the negative in front here. And it'd be pi over 2. And then x minus 2, because I'm shifting 2. And then minus 1 there. So any 3 of these answers are suitable answers. And you could come up with other ones as well. They're just different shifts and different flips. So, okay, hope that helps. I'll stop this one.